Hello, everyone. Welcome to our binary episode for this week, and the last podcast episode before our winter break. I'm Spectre, with me is Z. We'll cover the Spot the Vuln challenge for this week, and then we'll get into some of our topics. So, Z, take that away.
Yes, this week's Spot the Vuln was very similar to last week's, except I made a couple of patches or improvements to it, which unfortunately you can't see because an ad popped up. Apparently I don't have uBlock installed right now. Thought I did. Anyway, um, on that note, very similar to what it was. What ended up happening in this case is, and this actually was a bug that existed or exists actually in several binary search implementations, including those found in some textbooks, existed for like 8 years in Java and like the Sun implementation of binary search. And it basically just comes down to that middle calculation again. This time, while it is more accurate, it would be harder to detect this as a fault. The issue here is that end plus start can still overflow. So you don't necessarily need to have a array that is more than like the maximum int32 number of entries in it. About halfway there, so two numbers getting added together can get to that point, leading to I basically truncation in this case, leading to potentially a negative middle value. So an out of bounds access. And I should clarify in the case of Java, I'm pretty sure how it would end up treating that negative index is just the crash because it is a memory safe language, or at least safer. Um, but the bug itself existed there. I
Which
don't
is
think
kind
it
of
was
insane.
exploitable there. Yeah. Um, the I do have a secondary link here that kind of goes into, I guess, a bit more detail of this bug. At least for those of you here right now, you'll be able to see that. Just covers it and covers kind of the fix to it. Um, but yeah, I mean, really just that bad calculation again, giving you an overflow.
Yeah, I mean, it's pretty insane that this existed for so long in real world targets, like you were saying. Because I mean, this one is easier to spot than the last one we did, I think, um, or at least it was like for me. Which, yeah,
Yeah, with I think part of that's because this one is logically correct. Like you run it through, and that's why it took so long to spot, is it's not obviously incorrect. It is calculating the average. Most cases, it's going to work just fine. It's that edge case where you manage to overflow the two values, the start and end indexes. You overflow those, and that's very much an edge case because most people are not giving arrays that massive to anything. And
yeah. The only
especially if
way
this
you're
were 64-bit.
Yeah, the only way you're really going to be able to catch this is if you were explicitly looking for it and testing for it, or like fuzzing or something. Which um, binary search seems like one of those things where it's probably not going to be fuzzed all that often. Um, or if it is, it's going to be through like other paths that have checks and whatever. Like it's probably not going to be fuzzed directly, I should say.
Yeah. I guess you might set it up now that you've seen such a bug. But yeah, it lasted for a while. Part of that's because it's in textbooks, and this was quite a while ago, like the 8 years or whatever Java had it. That started in like 1998, patched in 2006. So like it's been a while since it was that prevalent. Nonetheless, it's still an interesting bug in, real code.
Yeah, I think it was a cool challenge. All
And
right,
fun to
so
have kind of two that work back to back.
yeah, yeah, for sure. All right, so we had some last minute news that we decided to tack onto the podcast today, which is an announcement from Hex-rays. Hex-rays decided they want to turn into Adobe, and they've turned IDA into a subscription model. So, for those who might not be aware of how IDA worked before, basically, um, you would be able to buy like IDA Pro as a base. I think it was like $1,000 or something, and then you would buy individual architectures as like an add-on on top of that, and you would pay for continued support. So you would buy the initial product that lasted. I think you got support for a year, and then after that, you could keep paying to receive updates, or you could stop paying and just stay on the version you were on. IDA has always been really expensive. That's been something we've hammered on this podcast quite a bit. But at least there was the perpetual fallback that you had access to. Well, Hex-rays decided that they don't want you to have that anymore, so they changed it now. So, for one, you can't even buy the individual add-ons and kind of mix and match the architectures the way you want. You have to buy their set bundles that are shown on screen now for those of you that are watching. They also have made it so when your license expires, you lose access to it. So it's very much like Creative Cloud for disassembling, which is really unfortunate. Um, I actually can't believe they did this, and you know, it sucks so much because we've talked shit on IDA quite a bit in the past for like its pricing model, or Hex-rays, I should say, and kind of recently, I was kind of moved like the needle moved back a bit when they released the IDA free for 7.6, which had the free cloud decompiler. I was like, okay, cool. It looks like they're making some moves to make IDA a bit more accessible in lieu of the alternatives that are popping up, right? You've had Ghidra for a little while. Bincha has been improving. Um,
Yeah, I
so it
mean
seemed like they
it's
were trying to move into like a positive direction, but then this comes out and I guess that's not the case.
it still felt like a little bit too too little too late sort of situation. Um Even with that it was a positive, like in the right direction, but still not something that yeah, out of chat IAPR mentions the tone deafness. I guess that's for what's Hex-ray and Adobe gone common. But yeah, just kind of deaf to the general community. And that's definitely kind of happening here. Nobody likes the well, sorry, only the providers like the subscription model.
Yeah, it's not super friendly to the consumer at all.
It's
Um,
entirely hostile to the consumer. Like I
yeah,
think they make, the whole well you can budget easier argument. Well, no, I can't. I mean, now I have to include this extra expense in the budget every year instead of, being able to at least have the option to not do that and miss out on some features.
it's funny how they tried to put like a coat of paint on it to make it sound like it was a good thing for you that they were doing this. Because yeah, for those who can't see the page, um, they they wrote that like they hope that it allows people to like budget easier or whatever. It's like that doesn't really mean anything, but
Yeah, I
okay.
guess we should mention that they did drop the prices on, in a sense. So prices, I didn't go and take a look. I mean, this was just from today. I didn't go take a look and see exactly what the old prices would have worked out to, but they say they dropped them by about half. So in that sense, there is some benefit. They have removed some of the options. You can't pick and choose your compilers anymore. It's just they have the different bundles, x86 bundle or one adding on ARM and then one adding on everything else. So like they've dropped prices there, yes. And that can be a benefit to some people, but I mean, I hate the subscription model. It honestly, that is the big killer for me. I mean, granted, I've already been trying to move away from Hex-rays on a whole, but I don't know. This
Yeah,
whole thing just feels like they're missing it a bit.
the timing seems really strange on this. Because like we've kind of been talking for a while about there being a potential move from like shifting enterprises from using IDA to something like Ghidra. Now I have seen some arguments about that actually, which I do want to bring up in a few minutes because I do want to talk a little bit about like where IDA is positioned now with this new model and how much that could potentially impact people's usage of it. But I will say, like, their bundles at least are kind of reasonable in the way they structured them, in the way that x86 64 is the cheapest. that is going to be the most common architecture for most people doing reversing. Most people are doing like Windows or whatever. That's going to be x86. Above that is ARM and ARM64 for mobile and whatever else IoT. And then they have the Ultra package, which is like $8,000, which has everything, including MIPS and PPC. So at least their bundles kind of make sense. And I guess like even the Hex-rays core bundle, which is x86, 64, ARM, and ARM64, the total price for that for a named license is $5,000, which I mean that's not terrible. I actually think that would be cheaper than the old prices were if you bought like IDA Pro and x86 and ARM all together. I think I don't remember what the exact prices were, but I think they were in the neighborhood of like 7 to 8,000. I might be wrong on that,
Yeah, what
but
they
that would fall in
mentioned,
line with what they said with the 50% have like
yeah,
prices. So
they mentioned having the prices, so I would assume it's cheaper. I'm just going to go with the fact that they're not lying by that.
yeah,
Taking one question out of chat there from Pyro ESP, is Ghidra a good replacement for Ida? I have pretty much no experience with RE. I would say kind of unequivocally yes. It's a so as you're indicating that you have no experience with RE. I think Ghidra is where people should start with. As much as I'm a fan of Binja, which we may touch on here in a bit, but Ghidra is, I think, the place people should start with any of it. Don't waste your money on like Ida Home or something. I don't think Ida Home by any sense is worth the price. I'd assume Ida Pros you're at least going to be getting the plugin system again and some of that. So
yeah. I
maybe
believe
some
the only
benefit,
difference
but
with the bundles above IDA Home is just the architectures you get. So
yeah, that
at least that's what the
seems to be
page
it.
indicates.
It's still fresh news, so we might be mistaken about some details. But yeah, Ghidra is really, I think, the best place to start off with. It's a fine tool. I mean, there are some issues. Yeah, IDA is the best tool available. I can't say anything else necessarily better than it, but Ghidra is not like a bad option, especially at the price. But even if you had to pay a little bit for Ghidra, it would still be a better option, I think. Or sorry, I'd still like the superior option. Ghidra, though, if you're starting out, there's no problem with not using the absolute best. Odds are the differences don't even matter to you yet.
So the one argument I have heard against Ghidra is its support for like ARM and stuff is not quite as good as it is on IDA, or not even really up to par with like what Ghidra does on x86.
Yeah, but
The
if
other
you're not
thing
making
is,
any money, like if you're a hobbyist, you're new, I wouldn't, not you're not going to start by getting the Hex-rays core, so you have ARM decompiler.
so I'm mostly making this argument for people who aren't hobbyists. They might be making money, but they're not making enough money to justify buying IDA. Um, that's kind of the position that I'm looking at this from. So I mean, yeah, and the other thing is too, like things like Windows. We've talked about this pretty much every time we brought up IDA, but IDA has really good support for like Windows APIs and things like that, which make reversing Windows binaries a lot better. I think it has stuff like that for iOS as well. Whereas Ghidra, you don't really get that. So like IDA definitely is the superior option in terms of pure like quality of what you're getting. Um, yeah, it is really unfortunate with this pricing model because the biggest thing that we've always complained about with IDA is the prices, saying they're just way too high, and these prices are bringing it more in line. I mean, um, IDA Pro with x86 and 64 is still $3,000, which like if you want to compare that to Binja commercial is like 1,200. But but the subscription model kills it for me. If they had just lowered the prices, like this would be a great move, and this would be a totally different discussion. Because I think these prices are like a lot more reasonable than what they were before. But
Yeah,
the no
I
perpetual
agree.
fallback is just so shitty. So
Yeah, that really is the main thing. Like because you can. even as a hobbyist, like you can save up for some of these things too. Um, but if you have to do it every year, that's not really an option. So
Yeah,
I mean,
Brindley.
like I agree. If it weren't for the subscription thing, I'm still not a big fan. Like I would have liked it had they just introduced more of a student pricing option. Um, or maybe they do. I actually don't know about their academic discounts. Um, but something that's like more targeted hobbyist, but still full featured. I mean, Idaho is kind of a joke.
Oh yeah, nobody should buy that. I can't believe they're still offering that. I can't believe people are buying that. But yeah, Brindley mentioned in chat it's around $4,600 for two decompilers under the old model for initial year, but about half that each year after. Yeah, that makes sense. That that roughly falls in line with like what I remember, because I remember like I used to have like the price table that they had, but I did a quick look while you were talking earlier to see if I could find it in like cached versions of the page, but I couldn't. Um, so yeah, there's a lot of people that are understandably unhappy about this change, voicing it. It will be interesting to see if it makes much of an impact in enterprise, because I feel like in big corporations and in government, it doesn't matter. They're going to be paying for support anyways. So this probably doesn't really impact them all that much. In fact, the licenses are just going to get cheaper for them. Um,
Actually,
but
that does remind me of one thing. It does seem like they might be making it a little bit easier to purchase because they do talk a bit more about their web store. Which I mean, I know just buying IDA is a bit of a pain going through their whole sales system. Um, it just sounds like with their new web shop, it'll be a little bit easier, but that's yet to be seen. That's not explicitly towards the enterprise, just in general, the purchasing might get easier, making it at least a bit more accessible to people.
yeah, that's an interesting part of it, because for those who might not be aware, like you couldn't buy IDA before if you didn't have like a verified business email. Not that that's like a high bar to meet, but if you just tried to send them an email like I want to purchase IDA and you're sending it from a Hotmail address, you're not they're not going to respond to you. So yeah, I mean that could be a, a minor positive here, is that it looks like it might be more accessible in that respect. But yeah, I mean, so in terms of like enterprise, I don't think this change will really affect them. Like I said, they're going to be paying for support anyway. Um, and in industries where there's a lot of money involved and you need the best of the best, it totally makes sense to just keep paying for IDA. For like the hobbyist, or the not the hobbyist, I should say the independent researcher, like people who aren't working for, $1 million corporations or something, I think there will be a bit of a move to Ghidra, if there hasn't been already. Like I think this might be enough to drive the needle far enough on the dial to get people to at least consider moving to something else. I did want to get into a bit of a discussion about the alternatives, though, just in terms of usability. So there's been people bringing up Binja with this change, saying, I wonder if this will make people go to Binja. And I want to talk about that a bit
I
because
don't think so.
yeah, I don't think so either. Unfortunately, Binja just isn't at the feature parity of what IDA provides. It's not even really a feature parity of what Geecher provides. Um, the
In
Binja
fairness to
decompiler,
Binja, like Binja is far, far more immature than Ghidra. I mean, Ghidra is newer in the sense of like the NSA release of it, but Binja is,
it's been in development for
a
decades.
handful, yeah, a handful of years old. Like it is an immature product, and it shows. Sorry, go ahead.
Yeah. So like Binja just doesn't, like somebody who's using IDA and is doing hardcore reversing probably isn't going to have a good time if they're trying to migrate to Binary Ninja. That's just the unfortunate reality of it. Um, there was a bit of an interesting discussion I saw about like IDA versus Binja and why Binja hasn't really been able to um, be as effective, or it's harder to use from a reverse engineering standpoint. And that was the fact that IDA was kind of built from the ground up based on type information, having strong type information, um, and then working off of that. Whereas Binary Ninja, it seems like kind of an afterthought in a sense. Um, and I talked to Z a little bit about this before the podcast, just because I was curious on what his thoughts might be on it, and you kind of disagreed. So do you want to elaborate on that a little bit?
Well, I don't disagree with that statement that like Ghidra is or sorry, that Binja is kind of lacking on the type information side of things, because it definitely is. And just in the way that they've had their approach is that they've kind of worked without that data. Their decompiler just kind of works generically, um, rather than incorporating some of that along with it. Where I disagreed with you before the podcast was on whether or not that was the necessary approach and if they'd have to kind of rewrite Binja for it.
Yeah, sorry. So I did forget that piece of it. The other like part of the discussion I saw going on was that like Binja was fundamentally flawed at the foundation because it doesn't put a lot of importance on the typing, um, and that yeah, you would have to basically like do a rewrite of it to put it in the right direction. So yeah, sorry, that's what you disagreed with. So I'll let you elaborate on that.
Yeah, and my thought is like for what Binja's done, I think it's just more a matter of they need more polish, they need more time and maturity on it rather than needing to entirely redo the system. It could also be a little bit of just a different perspective on things, just in the sense that Ida's Binja comes out, if I recall correctly, they were CTF players.
Yeah, that's correct.
Yeah, like I mean Vector 35 also, I mean I most remember him actually over the Opponent Adventure games, but yeah, like kind of that style of reverse engineering in line with exploit development rather than kind of that pure reverse engineering, figuring out exactly what source, what compiler flags went into producing this exact output. And I think that approach does kind of lead to some different design decisions. And we might end up seeing more of those trade offs coming up. Like, I mean, they kind of cluttered it with the whole, oh, the size conversions in their decompiler output. There's all that clutter with like the sq.z and all of that being in there, to indicate like signed keyword conversions or whatever was being done, which I personally really liked. That was a feature that I liked. Um, and I don't think you really see that in IDA. So I mean, it's one of those things that it's a different approach. I don't think it's necessarily worse. That said, because I probably sound like I'm maybe shilling for Binja here, I've been backing away a little bit on that front. After with the decompiler, had some excitement over that because I do like the ILs that they've introduced. With the price increase, though, it just doesn't feel justified from them yet. And that's kind of a killer. I mean, at the old, what was it, like $150, I think.
Yeah, I think it
Um,
was 150 for the personal
and
back
the
in the day.
imminent promise of dropping like multi-threading down to that personal level and stuff too. It felt a lot more approachable.
Yeah, that was the kind of turning point for me a little bit too. Because before the price hike, I was totally on board with Binja. Um, and even at the time when they did the price hike, I was kind of okay with it. I was like, okay, well, they're launching a decompiler with it. It makes sense that they're going to charge more. You're getting a lot more. But over time, um, I do feel like those prices are a little bit too steep, and it has made it a bit of a less viable alternative than it used to be. Um, Especially with Ghidra as an option. If Ghidra wasn't an option, then it would be a different story, but it is, right? And while Ghidra has its weaknesses, most people will joke that the weakness is that it's Java. No, the main weakness with Ghidra is that it's very slow. The analysis speed is extremely slow. But if you can work through those, then it's a way better option. Now, I will say IDA is still an option you can use if you're doing x86. Um, IDA free 7.6, like there's nothing to knock on it. Like if you need to decompile or disassemble x86, and I think IDA free is a really good option that you should consider. Um, the decompiler is in the cloud, so there's a bit of the privacy concerns I've seen people bring up. I mean, if we're being honest about it, I don't think Hex-rays is going to be stealing your vulns from you know a, a cloud decompiler output. I
Yeah,
mean, if
that
that's a concern
said,
for you, then you should probably be buying the pro version anyway.
yeah, I
But
mean, that said, I understand the concern less about actually thinking Hex-rays is going to do it, and more just about the idea that this potentially proprietary information is being passed to a third party. I mean, especially when you're working with another company, maybe you don't own what you've been given to test. Perhaps you're just the one that's supposed to be testing it. You may have signed like an NDA, although in that case, you don't use a cloud version. You're expected to not be
you're
sharing
expected to
that
pay
with
for
third
it.
parties, even if it's unlikely to be found out. So it makes sense in that sort of situation, um, to be concerned about Hex-rays.
Yeah. Along those lines, I have seen some interesting questions about how this licensing is going to work. Because obviously, the idea here that it's not going to be a perpetual fallback means that, like, is IDA going to be always online? Like, they have to know that they have customers that are going to be wanting to install IDA on air-gapped machines or on machines that are on their own, like, isolated networks. So it'll be interesting to see how the licensing is actually implemented with the way that they're planning to do it. Um, I don't know if it's maybe like every so often it'll try to connect to a server and check it, but um, you know the, it's kind of along the same concerns as like the cloud decompiler is like there are people who want to keep all of their stuff offline, and this price model or subscription model change could end up affecting that. So yeah, I mean, it'll be interesting to see where this goes and what happens as a result of this change. I saw you pulled up the date earlier. What's the exact date that this goes into effect? I think you had the transition plan up. I'm just trying to find it now.
Oh, it
Um,
does say from 2022-0101, so basically New Year will update the
okay,
catalog of products available under our subscription model.
okay. So if you have IDA right now, it probably would be a smart idea to try to renew it before the end of the year, so that you don't get caught up in this. If it'll affect you, if it won't really affect you, or if it'll benefit you or whatever, then obviously it doesn't matter. But um, yeah, keep that in mind that there is still a bit of a time window before they transition to this new subscription model. But um, yeah, and Brinley mentions like selling to defense contractors is going to be a hard sale if it has to be online. Yeah, I don't know. Like it's,
I
I mean,
imagine they'll
we've
offer
always talked about this.
I imagine they'll just offer, actually they do already have a in-house server that you can licensing server you can run to keep it offline.
Oh, fair enough. So you can kind of proxy it. Okay.
Yeah, I'm not sure if that's with all of the floating licenses, but I know that that's um an existing option.
Oh, okay. Brinley clarified they meant for existing ones, like existing named licenses if they require online. Yeah, like that's what I was gonna get to. Like again, this kind of seems like Hex-rays being like really tone deaf and not really understanding their user base. Because if they make it so that named licenses have to connect to like a central server, um, then yeah, I think people might get forced to change to something else because that might not be something they want in their setup. So really weird. I don't understand why they would make this change, but they did, and it's very relevant for our community because reverse engineering is a big part of not only malware reversing and stuff like that, but it's also a big part of exploit development. If you're doing any research on like closed targets or not open source targets, so yeah, this will be some big news for anyone doing like Windows stuff. So wanted to put it out there. It's an unfortunate change, but it's kind of in line with what Hex-rays does. They just don't really seem to care what other people think. So,
I mean, it makes
whatever.
sense for them. It's like I can understand their reasoning for it. I just don't like their reasoning for it. And
Yeah.
yeah, I mean, on a whole, consider Ghidra.
And Brindley mentioned, I wonder if they will back out. I doubt it.
They didn't back out of home.
Exactly. They still
I
haven't
can.
backed down with home. They're still trying to sell it for like $300. So yeah, considering they wouldn't even back down for that useless product, I doubt they do it for this. Home makes sense, kinda. I'd be interested on your reasoning for that because I think home is actually worse than IDA free. Um, it makes no sense to me as a product. So I'd be interested in what your arguments would be for that because I don't understand it. I mean, you get support. Oh yeah, okay. I mean, maybe if you really consider the support heavily. I mean, I don't know how important that's going to be for like a hobbyist that's doing reversing, which is kind of who it's targeting. I don't know how useful support is going to be for someone like that,
Yeah, I mean,
but
Brinley mentions, what
maybe.
about home in high school? At that point, I'd say Ghidra. Or if you want to spend the money, Binja. It's not, as we've kind of been saying there, it's not the best tool by any means. But I mean,
But it
it's
makes more
not.
sense than Home.
Yeah, even well, actually, I guess pricing wise, 300 versus 350 actually doesn't make that a great comparison. Yeah, I mean, and mentions Ghidra wasn't available when you were in high school. Yeah, I mean, but it is now, and it has been since they've introduced home.
Yeah,
Oh,
I think Home would have made sense if you launched it like
had they
earlier.
done
If
it
you launched it years
before,
ago.
sure. It
Yeah,
actually
now
could
it
have
doesn't make
gotten
sense.
some. Actually, had they done it without any competition, without Binge already being out there, without Ghidra being out there, Ida Home actually would have been pretty solid of an offering.
Yeah.
Um, but the fact that it's done in response to the competition, you've
Yes,
got
it's
these other things.
backwards.
Yeah.
It's backwards. But yeah, we'll kind of stop the discussion there. But you can check that out. The link is in our blog post of the episode if you want to see exactly what the prices are and what the plans are, and they have like an FAQ and stuff, so you can check that out if you're interested in more of the fine details. So yeah, we have a good mix of interesting issues today. Not really any meme bugs. There are one or two simpler bugs, but we'll start off with a cool one that was detailed by ZDI. This was a bug that affected both Chrome and Edge, or Edgium, as I like to call it, which was used by Bruno and Nicholas at Bone to Own Vancouver 2021. This is the second part of a three-part blog series on ZDI's blog. The first part is mostly talking about setup, talking about like the commit that introduced this bug and getting a debugging environment for playing around with it, which we'll mostly skip here. But you can check that out if you're interested in playing around with Chrome.
Yeah,
Um,
there's a good bit of background in it.
yeah. The second part here, which we will talk about, is the kind of root cause analysis of the Vuln. There is a third part, which is exploitation, but that hasn't been released as of yet. So we'll have to keep a lookout for that to drop. I imagine it'll be probably a couple days because it was a few days between part one and
Yeah,
part two.
I'm surprised it hasn't dropped yet, actually, because the first two. Okay, actually, maybe tomorrow it'll drop, going by the timeline and business days. But yeah, this one though, I'm really interested to see where the exploit went with it because of the primitive you gain. Because in this case, jump right in here. It comes down to kind of an issue, one around the optimization pass and around the wrong implementation, I guess what I'd say. Um, was the POC only on the first post? Oh no, it's literally right here. um, Fairly straightforward. Only five, actually not even 5 lines. For the actual bug code, obviously you have to control when optimization runs or whatever. So there's a little bit more to reproduce this without access to these primitives. But the actual bug happens really just around these 2 lines. which is creating a UN32 array, XORing the first inside of a function that gets optimized, XORing the first element of it with 0 and adding 1, which is a weird POC. So what's going on here? I thought they laid it out kinda. They didn't explain all the background as to why this happened. I'm kind of curious about the code. But the gist of all that happens is when they look at the patch, and I will bring that up also, is in this function change int32 to int64, the old code would look, is the provided argument here, is it a signed value? If so, does a signed move into a 64-bit register? If it's not, just does a normal unsigned move. Makes sense, except for the fact that change int32 to 64 should only be working with sign. There is a change uint32 option also, which would do the unsigned version of this. So the fact that it's considering it here is at least one key part of the bug, is the fact that it will do this unsigned move. So coming back to the bug, this gets combined, or kind of is seen, and you consider what this looks like during the different stages of the optimization. It loads the typed elements, that's going to be the unsigned value. It'll do the bitwise XOR on it. And that will implicitly convert it to a signed 32 int, or signed 32-bit value. At which point it then loads constant and will do that add, which is expecting or it loads the constant, which is a 64-bit for the number 1, and it does an add, again 64-bit. So all of that works out, but of course you get on to optimizing this. One such optimization that it does is it will see, hey, this thing, this XOR, this is with 0. You can prove that this will be a 0 value. That can be optimized out. So while it starts off just loading it, does the XOR, does the change in, the optimization path just removes that XOR operation, which would have converted it into a signed integer that goes into the N32, leading to it passing a unsigned value. The unsigned 32-bit value that loaded gets passed directly into the change int32 to int64, which is where you have this bug. They don't talk about how they exploit this one, and I'm really curious to see, just because that primitive isn't a huge primitive. And thank you, Mythical Gray, for the Prime sub. But yeah, I mean, that's the gist of this bug. I don't have a good guess on how they're exploiting this one. I don't know if you've got something, Spectre, because usually you kind of see this where if a signed extension happens, you can have some clear bugs indicated there. In this case, you're kind of going the opposite. You can have a negative number that doesn't remain negative when it gets extended out. And that's kind of the demo that they end up showing with this, is they have the interpreter result gives you the negative number, and the GIF result ends up being the positive number.
Yeah, so that actually tripped me up a little bit when I was reading it, because I was a bit confused on what the actual cause of the bug was, and that was for a few reasons. One, I was kind of thinking that the problem was that it was getting converted from an unsigned to a signed, but it was kind of just the fact that unsigned was going through. The other thing was, if you look at the patch, it's very weird because let me see. I think you have it up here, yeah. You can kind of see it a little bit in the diff window. So this change int32 to int64 supports different word sizes. So there's different, like, it has a switch block, and it has cases for like the different sizes. So the patch here was in the keyword 32 case, but there's cases above it for like keyword 16, for example, where the code is still the same as like the vulnerable code was for the 32-bit path, which seems really weird to me, because then wouldn't this vulnerability still be present with like the 16-bit path. Now, there's probably some nuances there that I'm just not aware of that makes it so that's not the case. But it did kind of confuse me when I was trying to like work backwards from the patch and figure out what was going on here. Um,
Yeah, it threw me off too when I looked at that patch, trying to understand what was happening here, and I pulled up the code. Yeah, saw the same thing. Like this same vulnerable pattern is there. Um, my only guess was either dead code, which doesn't seem too likely considering it's Chrome. Um, my other thought was it's just like those are different cases effectively. Like perhaps the unsigned function that I saw existed is kind of a newer addition, so now all 32-bit cases should be coming through signed, but the other ones can still, not be signed. Or perhaps it's specifically because it's converting, I guess, actually, yeah, and the name is, int32 to int64. So in theory, you should be having an int32 coming in by name. So I don't even see where it's coming with the 16. I don't know. I mean, it's a little bit weird there. I assume there's some reason for it. I don't know Chrome internals enough to actually reason about that, unfortunately.
yeah,
Um,
neither do I.
it's just I'm hoping maybe we'll find out a little bit more with the next post. Like I said, I'm definitely curious to see how they leverage this exploit because it isn't the usual like signedness issue. I mean, I could imagine some cases where like this, because it is in a sense going to be a negative becoming a positive value. So I'm sure there's some way they are leveraging it, but nothing like familiar is coming to mind to me.
Yeah, and jumping back to your original question of like how this could be exploited. Yeah, honestly, I can't even really think of it either. My browser exploitation background is not extensive by any means. I've only done like one or two exploits in it. But I did learn a lot like doing that. And the thing I've always said on this podcast is there's so many things in the browser that such a subtle memory corruption can offer type confusion pretty easily, and then your world of possibilities kind of opens up. With this one, though, I can't even really begin to speculate how this would be taken advantage of. Um, it's a very interesting bug, and it's a very subtle bug. Like I would be very interested if this caused a crash if you were fuzzing. Like I don't think you could fuzz for this issue.
I
This
think
seems to be
it's going to
something you would have to
depend.
find with manual review.
I really think that's going to depend on how this does end up being exploited. I
Yeah,
don't
that's just
know.
my speculation, but
Because like I could imagine the case where you have some that's like, is this value less than, bounce check, assuming, it's um uh, assuming it's like a assigned value and working with that and having some optimization or something. I don't know where that's coming, but like I could imagine the scenario of it checks if it's less than some bound, and then because of this optimization, that flips and it goes positive well outside of a likely bound. Why I wouldn't be checking with 0 though feels a little bit off to me also. So I'm not sure, but I'm curious about it. Like it's an interesting primitive, as so many of these browser bugs are.
yeah. So, like you, I'll be keeping a close look for when the third part of this comes out, and I think we'll probably even cover it when we return in January because yeah, it'll be something interesting to talk about for sure. But unfortunately, we don't really know much more than that right now. We just kind of this bug or this post was just about root causing the bug, displaying what it is. They go through a bit of talking about like how they go through the optimization graphs and stuff like that, and um, how they work through that process, which might be interesting to you. But yeah, most of the bug is covered in like the first half of the post. All right, so we'll get into some of, I guess, what you would classify a bit more as the meme bugs. I saw you were talking about in chat about that.
Yeah, this
Um,
one I would kind of consider a meme bug, just
they are
because of
still
what
interesting though,
happens. Oh, it's interesting, but the bug itself does feel a little bit of a meme.
compared to the other ones in the episode. Yeah.
Yeah.
So this is a Project Zero report on two vulnerabilities found in libcontainer, which is used by Docker. The first vuln, I think, is the more interesting one of the two, because it's not so much a memory corruption as much as it is a logic bug between the handling of Golang code, which is used, and C code, like a C binary that's running, because they kind of have this interface where there's like RPC going on. So Golang will take a bunch of mount sources for a bind mount, and it'll send them over in a message to the C binary. And then that C binary will parse that message to do the actual mounting. Um, but the issue here is ultimately the fact that that list of mount sources is effectively just an array of null terminated strings. But Golang, being a higher level language, doesn't have any special consideration for embedded null bytes in the mounting source. So you can cause some confusion in how that C code is doing the parsing of the mounting source list, because you can inject null bytes. If you have any control over any part of a mount source, you can inject null bytes and kind of throw off the parsing there, and perhaps create your own fake mount source entries, which might be useful against something like a Kubernetes environment for getting around host path restrictions. So, yeah, I thought that one was a bit more interesting because it's not really memory corruption; it's just a difference of opinion, kind of, between how Golang deals with null bytes and how C does.
Difference of opinion. That is a nice way to put corruption like this. I guess
Yeah,
as you're saying, it's not exactly corruption. Well, it leads to the wrong processing. Yeah, I mean it is. It's a differential between two parsers. Also, if you want to go that route, desync.
yeah,
Phrase it a
desync's a
lot
good
of
way of putting
ways.
it
Yeah,
too.
like it's an interesting bug. Bit of an ask to like having that level of control at the same time. Cloud environments. It's plausible for sure. Um, yeah, because this does impact like Kubernetes, which of course has at least use in Google Cloud. There was another bug in this one also, which was an integer overflow. Basically just due to integer truncation. And again, this is in Go. They have this nice length or len function that just returns the length as an integer. Nothing too crazy, but in serialization and the way this is passed over to the C application or C binary is that it's expecting just a 16-bit unsigned integer. So it simply truncates what it gets out from the length or from the len call, truncates that, tosses it in. So you could basically have a difference between what it's sending over. It's going to send a lot more data than the truncated length. And that basically lets you inject your own messages. So it'll think that it's no longer reading a message, or it's no longer reading the original message, and you can send a new one, which can indicate things such as the attack vector that they talk about here is sending along the case that'll fall into basically having it clone the parent or host namespace for this new container. You can send it over, indicating that that flag is to be set, and um, it'll run as the host permissions. Often, that's going to be as root. So a little bit damaging there. And also like truncation issue like that feels like a bit of a meme issue. Some
That
that
one
should
for sure.
maybe be
Yeah.
checked for.
It is worth mentioning that you would still have to chain that with the first bug, though. They mentioned that you would need to be able to put null bytes in to be able to fix up the number of mount sources to get the messages parsed. Um, but it does give you more than the first bug on its own gives you, because you can now control flags and such and not just the host path. So it is a useful bug, but it does depend on the first one in a sense.
Yeah,
So did want to point that out.
yeah, fair show.
But yeah, I mean, the first bug, especially for me, was just kind of cool because it's almost like some of the attacks that you see in web with like HTTP header injection. It's kind of had that feel to it, but in a binary way. So that was cool. It
Yeah,
kind of
and
went the opposite way of what we see sometimes.
yeah, it's an app comparison. Request smuggling, I think, too. Kind of doing something like that, where we actually, I think we saw a request smuggling due to integer overflow one time.
Yeah.
Um, yeah, I agree.
So, getting into our final bug of the episode, we have an Android kernel bug that was found in the wild and disclosed by Jan Horn at Project Zero. And it's another instance of a bug that was patched in mainline, but somehow that patch failed to make its way into the Android forks. So, it's kind of like a bad binder 2.0, which is actually called out in the summary for this advisory. It did only exist in a brief window for the various kernel versions on mainline because the vulnerability was introduced in a bug fix for a previously reported vulnerability. So there was a bit of a regression there. The previous vulnerability that they tried to fix was an issue where it was possible for the EP loop check proc function for epolls could iterate file descriptors attached to it and end up adding non epoll files to an internal list that gets checked. But there was a race condition because it was possible for those non epoll files to get closed while they were still being checked. So in an attempt to fix that, they did some they tried to do reference counting on the file before they add it to the list. They used these get file and put file calls to do that ref counting so that the file wouldn't get deleted while it was being used. The problem with that, though, was it was possible for a file that was already marked for destruction before it even reaches that get file call to get through. So it might end up getting a file with a ref count of 0 and end up adding to that and continuing on anyway. So it's kind of an interesting like edge case that's actually really hard to think about. Like you could totally excuse this like bug being made because you have to consider the fact like all the different ways that a file could be used and the fact that reference count might not be reliable. Um, Jan Horn calls this an object state confusion because the state of the object is in a state where the get file call is an invalid call to make. That's basically the root of the issue is that um, in certain object states, get file just doesn't work. And
Yeah,
that case being ref count equals 0.
the patch here ended up being get file RCU. Um, I believe
Yeah.
they just straight up replaced that. Like it was a very easy patch too.
Yeah, and the reason that that works is getFile RCU will do an internal reference count check, and it will check if it's equal to 0, and then if it is, it'll bail out and it will return an error. So it's able to detect like whether or not that file object is in a bad state or not. Whereas the getFile call, it's unconditional. It just unconditionally increments the reference count and continues. So that's why that patch works. But yeah, a very cool and subtle bug. Only briefly lived for a lot of kernel versions, but because of how messy the Android patch pipelines are, um, there may have been a few devices that were vulnerable for a long period if the vendor cherry picked patches, which isn't really that uncommon. Um, the kernel patch process is still kind of a nightmare. They have been trying to improve it. Google has been working on like the generic kernel and trying to centralize patches, but it's still in kind of a rough state. So that's kind of how this bug ended up surviving in some of those devices for so long, and probably why it was found in the wild. So yeah, I mean, still the bug is really cool though. I like it's so subtle. Like if I was reading, I was trying to put myself in the headspace. Like if I was reading this code, would I have caught this? And I don't think I would have. Because I didn't really know what to look for. Like I wasn't really aware
Yeah, now
of
that you're
the implications
aware,
there.
it feels easier to spot.
Yeah, obvious in hindsight.
Yeah.
So, but yeah, if I was just reading this code before this report came out, I don't think I would have spotted this. So, very cool bug. Um, Given the nature of this bug, they heavily suspect that this was found through manual review of security fixes. Um, because, like I said earlier, this was introduced in a fix for a previous issue. So, that seems most likely. Um,
Yeah, definitely. It does talk a little bit about the variant analysis, calling out one looking for the fixed bugs that didn't get upstreamed. And also just code paths that extract a file from epoll and assume the ref count is non-zero. I am also wondering if there might be, if it might not be a bit more valid. Well, I guess not more valid, but outside of epoll, if somebody were using getfile, if you could still hit the same situation. I feel like epoll how it what you can get with some of the lifetimes is maybe also leaning into this one, but maybe adding a little bit more scope to look for variants. But
Yeah, ePol is a bit of a weird subsystem in the mix,
yeah,
so it's hard to say for sure. Um, it would be interesting to speculate a bit on if this could have been found through fuzzing, because that is sometimes talked about in like the Project Zero reports. They like to talk about the methodology. I feel like this one would be really damn hard to find with fuzzing because, I mean, for one thing, there's a race condition aspect to it, which fuzzing is already weak at like finding that style of bug. And then if you also include the fact that like there's the ref count involved and it has to be timed even more precisely, I think this would be really hard to find with fuzzing. I think this is one of those bugs that you're only really going to realistically find with manual review. So, and it requires kind of an intricate understanding of the subsystem in the way that you have to understand the implications of the get file call to like be able
I
to
mean the
spot this
fuzzer
bug. So,
wouldn't, but to spot it yourself, you would.
yeah,
Yeah,
sorry, I meant for manual review. So, yeah, I mean, just a really awesome bug and a really good write up too. Like it was really straightforward. I wasn't super familiar with like this exact area of code. I am familiar with Linux kernel, but not this area of code. So, and they have like a nice diagram there explaining everything too. So, yeah, good overview.
yep.
Um, but yeah, that's pretty much all the topics we have. We do have a shout out, and it's actually something that we somehow missed last week, so we wanted to make sure we got it in this week.
Yeah, and I was
Z, you're the one
sure.
who stumbled on this, so
Well, I was sure I had this like in the schedule for last week's episode too, and I don't know, maybe I added it to the bounty one and instead of this one or something. But yeah, from Seal, you have a actually it's a series of blog posts on, or at least there are a series of blog posts. I think this is the fifth one on exploiting Chrome browser and JavaScript engine in V8, going through a lot of background there. And then this fifth post is finally actually on a little bit of exploitation, some of the mitigations that exist within there, and vuln patterns in there. A little overview and look at it. I say little, but there's actually quite a bit there. So I want to give that a shout out.
yeah, quite a good shout out because it kind of pairs nicely with the first vulnerability topic we had too. So, um,
True.
yeah. All right, but that's all the topics that we have for this week. Thank you to everyone who tuned in. The VOD will be up on Twitch immediately or on YouTube tomorrow. We also have previous podcasts up on Spotify, Apple Podcasts, more links on Anchor. If you want to join the community, follow our Twitter and join our Discord. Links for those are down below or in the chat. This was our last episode before the holiday break, so we will be back on January 10th and 11th in the new year. Until then, happy holidays.